Right, what follows is an overview of the SEER sheet metal cost estimation capability that resides within CATIA V5. What Keith is going to do is go through the processes required to generate an estimate, review the results, but also how it can be, how the rules can be configured to represent your particular environments, and how the model can be calibrated to do that as well. This, as I say, is an overview, and more detailed questions can be covered in follow-up sessions. Keith, over to you, sir.
Okay, so what we have in front of us is a standard CATIA interface. On the top left-hand side, we see 3 new buttons. These are the SEER interfaces for composite, for sheet metal, and for machining. Today we're looking at sheet metal, so I'll just invoke that. As this loads, it will open up SEER for manufacturing in the background. It will then interrogate the part, look at the geometry, and present itself with this new dialog box here. The way the model works is it bases itself on manufacturing environments, which we'll go into a little bit of detail later on, and also rules files that are created for each individual environment, and a SEER for manufacturing model which is saved as individual knowledge bases, again, for each individual environment. So it's a straightforward process to create and build your own manufacturing environments. And if we look at the list, there's some sample ones that I've done for different people, but we'll say, based on the fact that this is a fighter airframe, this is going to be an aerospace component. It's made from aluminium, and like all of the other SEER tools, you can add your own materials to reflect your buying power, etc. We're going to make 100 airframes, and the shape complexity is nominal. We now decide on how we're going to bend this. So we can draw rubber, and this is taken from the comprehensive list of operational for bending, folding within SEER for manufacturing. So we'll draw rubber this component, and we then look at the process options. Now, the process options are one of the things that are controlled within each of the environments for each given part family. So for this given part, we're going to NC route it. We're going to drill route after form. So we've already told it that we're going to use a draw rubber. So we'll do some routing afterwards, and then we're going to finish it with some iodine and some epoxy primer. We'll say we don't want tool fab design. So these are controlled. These are simple yes/no operations that you can save for each part. So if you have cleats, it could be something straightforward. If you have some drawn stretch components, you can make this more comprehensive to reflect the actual process steps that you need for your given material type and part family. Drilling details, again, we can add part drilling, we can tell it what we're going to do, how we're going to do it, and this becomes a growing list. Tell it the quantity, the diameter of the holes, depth, pitch, etc., and if we want to ream them or not. I'll cancel out on that. So realistically, that's all there is to it. How we're going to bend it, choose the environment, tell it the quantity, just go through and concur that everything's right. So we could click in here and we can turn these on and off if we don't want to, if we decide to make a what-if scenario for a different process. We'll click on estimate, and very quickly it's interrogating the model, and it's going off. It's going to open up an estimate within SEER, and SEER will then bring the estimate back into CATIA for you to view the results and have a look at the impact for your estimate. So we have our setup minutes, direct minutes, inspection, and rework. The cost is a function of the labor rate within the knowledge bases, which would reflect your buying, whether it be in rupees, whether it be in sterling, whether it be in US dollars. The material cost comes in based upon the material selected, and again, like I said, add your own materials, make the model, and fingerprint it to yourself. Let's have a look at the estimate. So we click on Show SEER, and this is the estimate. We have a General tab, and I'll just expand this box. So within here, the green is represented by what we entered within the CATIA interface. The yellow is a rules file, and the blue is set up within the knowledge base for this given component. So when this was set up, it was set up with production experience of high, product classification of very high because it's an aerospace part. And if you look at this, you just look at the help, and it helps you understand what the settings are if you need to. Just verify, validate what you're doing, and are you doing it correctly. Click on OK. There's labor calibration, which is a linear multiplier. We have learning within the model, and you can capture learning. You can turn learning off. You can tell the model to use on prior units. You can do step learning. So you can really fingerprint your given environment and scenario that you're trying to emulate for your production facility. Within the process facility, process specific tab, we have a part length, part width, part area, and thickness, which has all been brought in from the CATIA interface. The rules file has decided that these were the operations that we saw in the list: NC route, draw rubber we selected, drill route after form, and so on. And as you can see, these are just simple yes/no options based upon multiple thousands and thousands of parts that were analyzed. The parametrically driven version of this allows you to do simple yes/nos rather than saying the routing length is X, there's 14 bends. It really does do a great job. Level of mechanization, shape complexity, part utilization, again, coming from the rules file, coming from the interface, and coming from the knowledge bases that have been created. Tooling, we turned that off, but that could be on if we selected yes. Part mark and inspection are all here also. So if we return back, we can have a look at doing something different. So let's modify the estimate. We go back to the part inputs, and this time we're only going to make 10. We've decided that the part is probably a bit more complex than we thought. We're still going to draw rubber it. Our process options are there, and we'll estimate it again and just simply see the impact of making a lower quantity. And as you can see, we've added a lot on, but that's really because of tooling again, material, etc. To have a look at that. So let's go back, modify the estimate again, go back, have a look at it. We want to make 100. They were nominal. Process options, etc. Leave that one there. So these we can say no, and we'll re-estimate that part without that operation in there. And we've made a saving because we've changed the process, etc. That's how the model works. Now, I've spoken of environments, and let me just go back to modify the estimate. So these are the lists that are in there. If I just go into the environments, we'll have a look at what we have. So these are where the environments reside on your desktop, on your computer. And it's simply a case of taking an existing one, copying it, renaming it, and tailoring it to your own type. So actually I will do that so I can save it. Manufacturing, I'll take that one, I'm going to copy it, I'm going to insert paste, or paste actually, paste, right click, rename, I edit, so I go into change that, I open the first file, which is the rules, and I'll maximize that. So if I come to the top, it's already been renamed. Because I'm living in England, I want to make it in British pounds. Aluminium is good. I won't change too much, I'll just go through and show you the sorts of things you can alter if you wish. So brake forming, and it tells you with guidance at the top what each one's for. Material types, process types. So this is the list. So if we're going to break format, it's going to come in, and these are the yes/no options for the tooling if you want to make them. Machine control, medium, break dies, so on and so forth. This is the different operations up here. Draw rubber. So for draw rubber, we had a form block, and so on and so forth. So we can make all the edits we want to do. This works in conjunction with a file, which is a SEER for manufacturing file, and it's this one here. So if I open that one, this will create and save knowledge bases specific to this environment only, and it's what will be used with the model. So here they are here. They're forming. So I'm going to go options, set project parameters. I don't want to work in dollars, I want to work in pounds. I'm going to save that. Learning, click on OK. I can make changes here. I can work in a labor rate. We're going to work cheaply today and change that. And likewise, that could be rupees, that could be sterling, this could be euros, dollars, etc. Our production experience, we have some very good guys. So we're going to improve their capabilities. We're going to remove that calibration value down to 1. We're going to change the learning curve to 85. And just a few random changes to show you what we can do. Based upon that, I want to just make these changes across the board. So I'm going to just copy that one. Paste. And paste. Paste. And paste. We're ready. I'll save that. Hold on. Go back into here, delete that. I'd opened it as a read-only file, so that's all I needed to do. So that's ready to go. I come back, and in my Excel file, which we started with, at the very top end, we can now save the environment. So I'm just going to update the knowledge bases, and this is going to save this rules file. It's now going to open the MFG file. It's going to save it. Each one as an individual knowledge base associated with this given environment. There it goes. It's doing them one at a time. And when that's finished, we're ready to go. Restart CATIA. Reopen our part. And sheet metal estimate. So we can change our environment. KG edit, draw rubber, production quantity 100, and estimate. And hopefully it'll be cheaper because I've actually changed some of the environments and so on. So that's how the model works. If we go now and show the estimate, it'll show you the level of detail that we can get out of the model, how the model can be set up. Our detailed report for this one will show you where the time has been expended. We have our setup minutes, direct minutes, total minutes, our first unit minutes, and our estimated minutes, which is our average production unit cost. So we can see that for the component, and all the way through we have this level of detail and granularity. These can be exported, these can be copied, paste special into Excel or any other of the Microsoft products, where you can critique it, you can refine it, you can add your uplifts if you want to for SEER. So that's basically it. That's how the sheet metal model works. Back to Steve.
Thank you, Keith. Hopefully that provides the necessary overview, and I'm sure that will generate some questions which we can cover in a more detailed follow-up session in the near future. You have our contact details. Please feel free to get in touch should you have any questions prior to that. Thank you very much, and we look forward to hearing from you.